How's everyone doing this week? Keep hanging in there? Okay.
Great.
So let's see.
Mhm.
Last week we didn't get through all of Lab 3. Probably take about 15 minutes to finish that up. And then we'll switch over to Kate. And Kate's going to, as part, and Kate, want to introduce yourself now?
Yeah, if I can figure out where the heck your screen went to. Oh, there you are. There's sometimes when you really should just restart your computer.
Yes.
There's just too much going on. So hi, everyone. Kate Meredith from Glass Education. I'm here with Olivia Smithmeyer. She is an education consultant that works with us on all manner of things over here. And yeah, I've been working on making OPIS more blind, visually impaired, deaf and hard of hearing friendly for the last few years. And I'm going to talk to you about some of the stuff we've done and encourage you to seek out all the students with disabilities in your classes and send them my way.
And then when that's done, if there's time left, if not, totally okay. But if there's time left, we'll start going through how to do grading in WebAssign. And I'll show you the grading guide we put together to help make, I put together to help make my TA's lives easier, but instructors at the various institutions use it as well.
Can I
Okay.
ask a question?
Oh yeah, please. Yeah, go ahead. Yeah. Any questions?
This is a scientific question because this is the opportunity to talk with you about that. So this is about the combining four forces together. So basically, the electroweak and nuclear force, that is a strong force, weak force, and the gravitational force due to gravity. So force due to gravity looks like a whole Earth, very huge mass that pulls us like a 70 kilo, 700 newtons, and that is very weak force compared to the other forces, like the electrons is still they get attracted with the proton even in the gravitational field, right? And then we have a very strong force in the nucleus that even the protons can be bound together. So so this means that if we go very large mass, then there is a gravitational force, but this is a weak force. And that's why what is going on in that combining four forces together, basically it looks like as we go on larger mass, there is a gravitational force. And also that's why probably people try to sense the gravitational field through the gravitational wave and getting the graviton, because electrons is responsible for the electric field. Nucleus is responsible for the those forces, strong forces. So maybe the graviton, if we can detect that, we can know that is responsible for those things. So where that area going on?
That's the big question, right? That's the holy grail of physics. We have our three quantum forces, electromagnetism, weak and strong, two nuclear forces. And they've been able to, once you go to higher, so this is our low energy universe. The four forces exist separately. As you go to higher energies, electricity, electromagnetism, and weak combine, giving you the electroweak force. And we can probe that in our accelerators. And that theory has been extremely well tested. Richard Feynman did a lot of this work, and it looks great. Then in theory, you should be able at even higher energies combine electroweak and strong. Basically in the high energy universe, in the early universe where all this energy was floating around, you could create different particles, different than photons and gluons and the weak carrying particles that basically act as a super force that combines them all. And there are a variety of theories. These are called GUTS, grand unified theories. But to test them requires energy scales beyond the capabilities of our accelerators. You'd have to build an accelerator the size of the solar system or something like that. So that remains very theoretical. And then you have gravity. And this is the sticky one. Gravity is currently described by Einstein's general theory, and it's a classical theory. It has all sorts of weird modern physics stuff, but it's a classical theory in the sense that everything has a well-defined position and a well-defined momentum, which is the opposite of the quantum theories, where the better you know one, the worse you know the other. So how do you reconcile these two? And this has been the holy grail. And Einstein, he famously said, God does not play dice. And by God, he was a deist. So by God, he meant nature. And by dice, he meant the probabilistic nature of quantum mechanics. Even though he's the one who created quantum mechanics, he then hated its nature and spent the second half of his life trying to reconcile the two theories without success. And no one's been able to do it since. So that's the great mystery. Maybe they are just totally separate things. Maybe they don't maybe they don't merge. Most people are taking the approach of quantum mechanics is right, gravity has to be modified. And so they're trying to produce theories of quantum gravity. And there are two approaches to this. One is to introduce a quantized gravitational force carrier called the graviton. The other approach is to quantize the fabric of space-time itself. And so these are the two general approaches out there. String theory, for example, has the graviton approach. But then you have, I forget the names, but other approaches where you're trying to quantize the fabric of space and time. And none of these have really worked. Like string theory's been around forever and ever, and there are different versions of it. And about half a decade or probably a decade ago now, they realized all the versions are they're the same thing. They have this new super theory called M theory. Yet still, after 40 years, string theory or M theory or any of them haven't predicted anything that matches our universe. It's a nifty idea. But I fear that when we grow so desperate that
in terms of the astronomy,
yeah.
I mean, in terms of the astronomy, so the let's say astronomer theorists, what is that?
So in terms of the astronomy, we use general relativity for gravity, and in low field conditions we can use Newtonian gravity, but in extreme conditions we use general relativity. And for the quantum forces, we use quantum mechanics and quantum field theory and things of that nature. The only two cases where you really need the two theories to work together. Special relativity works with both. But to get general relativity and quantum mechanics or quantum field theory, whichever version, to work together, you need it in the centers of black holes, where you have a tremendous amount of mass in a quantum-sized space, and the Big Bang itself. And those are the only two places. And black hole theory is, am I being recorded? I don't care. I'll say anyway. Black hole theory is a clusterfuck, predicting all sorts of weird, wild things that they can't resolve. As the black holes evaporate, the information that went in mysteriously disappears, violating quantum mechanics. And they talk about firewall. It's a mess. Black hole theory is a mess, and probably will be until someone figures out how to reconcile these two theories.
Thank you.
Yep, it's a great topic, but that's the state of things. All right, other questions, or shall we dive into the remainder of lesson 3? Okay, let's dive in. Screen share. Mostly over the plague that I've been suffering. Spread you out here. Hopefully not too much hacking and coughing. Again, just the videos are being posted on our YouTube site. Here we are. We've had quite a few weeks under our belt now. We'll finish up Lab 3 today, do accessibility and maybe some grading. Let's see. I think I have Lab 3 open here. Okay, so last time, Lab 3 is doing two things. The primary thing is the Kepler third activity. And then the secondary thing is the Venusian phases, showing that we do live in a heliocentric universe, not a geocentric. And that's kind of the shorter, easier one. It's currently at the end of the lab, and we went through that last time. So we did the first background section, the different parts of the Galilean revolution, ending up in Venusian phases. And then we showed how it's easy to measure. I showed you the graphing tool where through this, the students can learn we indeed live in a heliocentric universe. And this is part of the story of our place in space, the name of the course. Okay. Now, the second part, Kepler's third, isn't really part of the story, the progression of Earth's not at the center of the solar system's not at the center of the galaxy's not at the center of the universe has no center. That's the progression of the course. But as we're going along this journey, there's certain things that we felt very important to catch along the way. In terms of misconceptions, the nature of the seasons, the nature of the Big Bang, which we'll see at the end. But a few other things as well, Kepler's third and the rotation curve of the Milky Way. These are things we've added into the OPIS curriculum because they're just so fundamental. And particularly like the rotation curve of the Milky Way, you can make use of stuff you've already learned. But anyway, this is the Kepler's third part. For the past couple of weeks, they've been monitoring a gas giant and moons going around it. So let's go through the background section quickly. This will introduce us to ratio astronomy, which I hope you're already using in your courses. Astronomy is great for the ratio approach. If you're new to it, you'll see it here. But we introduce them to an ellipse, tell them they can make their very own ellipse at home with 2 tacks and a piece of string. But the key things is you have a major axis and a minor axis. The major axis, I know you know these things. Again, I'm just kind of explaining them as you might to your students, just a little more quickly. The major axis is the long distance across, half of that. Half the major axis we call the semi-major axis, and Kepler's laws, Kepler's third law in particular is parametrized by that. It's labeled A, I guess, for axis, but it's the semi-major axis. And so Kepler's great discovery was the orbital period squared is proportional to the semi-major axis cubed. And he looked at all sorts of things going around all sorts of things and realized the constant differed depending upon the central body. Planets going around the sun had a constant, Earth going through the moon had a different, going around the moon had a, sorry, the moon going around the Earth had a different constant, and Jupiter's moons going around Jupiter had a different constant. And Kepler did not know why the constants varied. It wasn't until Newton came along and invented physics, he was able to derive this, had to invent calculus in the process, so you can actually motivate this under some simplifying conditions, circular orbits. I have a video on how to do this if you're interested. But really, in the lab here, we just say Newton came along, figured out the constant. It depends on the mass. It actually depends on the sum of the masses of the central body and the orbiting body. But planets are negligible compared to the sun. Moons, at least for the moons we're looking at, are negligible compared to the planet. So we just go ahead and simplify this to mass of the central body. Okay, now in your kind of traditional physics approach with the plug and chug, this equation can be a bit of a nightmare for students. Think about it. They're going to get the semi-major axis in AU. We're going to get the distance to the planet in AU, and we're going to measure an angular semi-major axis, and so convert that into a semi-major axis in AU. But G is usually given in the MKS system, so they have to convert AU to meters and then plug in G in the MKS units. The period will come out in seconds. They have to convert that to years. So that's a lot of unit conversions. It's plugging in fundamental constants. Lots of opportunities for students to make mistakes. And so this is why in introductory astronomy, whenever possible, we try the ratio approach. And it's challenging in the sense that it's a little challenging at first for them to wrap their mind around the process. But once they do it, the math becomes so easy. So for example, on this one, this is the general equation, holds for anything going around anything. Then you need a comparison equation. And for that, we're going to use the Earth going around the sun. Orbits once a year. It's at a distance of 1 AU. The mass of the central body is 1 solar mass. Okay. And then divide the two equations. The G's cancel out. The 4 pi squareds cancel out. So they're not going to have to input any of that stuff. You simplify, you get this. And solving for mass, you get this. So suppose I'm measuring a moon going around a planet. They can measure the semi-major axis of that moon in AU and the orbital period of the moon in years. It's the one number cubed divided by the other number squared. That's simple. A cubed over p squared. You get the mass of the central body. It comes out in solar masses, so there's still a unit conversion to do, but it's not that bad. The hard thing is for them to wrap their mind around the ratio approach, but then equation calculation becomes so simple. Another example, like if you're teaching, not just, we use this a bit in the lab, but if you're teaching this in a lecture and you're using equations, you should use this for almost everything. I think this distance is speed times time is the only thing I don't use this for. Take Stefan's law. Energy flux is equal to the Stefan-Boltzmann constant times 10 to the fourth power. In other words, energy flux is proportional to T to the 4. So once they get good at this, you can say, okay, one star is twice as hot as another. How much more energy flux? Well, it's just 2 to the 4. So 16. They can just crank these things out. They didn't need to use the Stefan-Boltzmann constant, et cetera, et cetera. All this makes sense? You probably use ratio approaches, but if you don't, I encourage you to do this. It's perfect for introductory astronomy. Okay, that's the background section. Then here's the section on how to monitor moons going around a planet. We talked about this previously. So they've been collecting data for 14 days. In a perfect world, they'll have 14 observations. They'll really, excuse me, occasionally they may only have 5 or 6 or 7. And you can get by with that. If you get less than 5, it's getting a little dicey because we're fitting 4 parameters. And so you need at least 4 data points and ideally more. Okay, how do we do this? So measuring the orbit. They pick their gas giant, Jupiter, Saturn, Uranus, or Neptune. For each gas giant, we've identified a moon, Ganymede, Titan, Oberon, and Triton, respectively. These all have periods between 1 and 2 weeks. These tend to be the most massive moons, so they're going to be the easiest to identify, that would be the brightest. And so in this box here, they indicate which moon they're tracking. Although it says it's only for 1 point, it sets the auto grading for everything else. If they're working on Ganymede going around Jupiter and they select Titan going around Saturn, they will lose a lot of points. So just be aware, it's a simple question, but it sets the auto grading. Okay, and then they're going to fill in, we have 14 lines here. They're going to fill in for as many images as they got, Julian date, and the angular separation. So now let me show you how to do that in Afterglow. So I have a sequence of images of Saturn. And as we talked about before, we're going to want to adjust the brightness and contrast. That's too much. Let me back it down a little bit where I can see as many moons as I possibly can. If I go too far, I lose the moons. I could probably go a little bit farther and see if I could pull any moons out of the glow in there. But there we go. Okay. And which one is Titan? Well, we'll use Stellarium for that. But again, the things they're recording are the time of the observation and the angular separation between Saturn and whichever one of these is Titan. So for the times, you go to the second tab, the image info, and they're going to grab the Julian date, either the start or the center. Technically the center of the exposure, but the exposures are so short, it doesn't matter. And the reason we're grabbing the Julian date instead of the year, month, day, hour, minute, second is we're going to put it on a plot. And so we really need it in a decimal form. And it's a pain in the neck to convert year, month, day, hour, minute, second into a single decimal number. So we just have them grab the Julian date and they'll stick that here. I actually have them go through all their images, fill that in real quick. And then for angular separation, I should say, once you've adjusted the brightness and contrast, you just did in the one image. Like here's the next image. And it hasn't been changed. But if you do it in one image, here's a little shortcut. Go to settings, sync display settings, go back. And now if I load any other one, see it change the brightness and contrast automatically. It saves them some time. Anyway, let's see. This one occurred. Let me bring up Stellarium. Where is it? It's behind you. Here it is. So just in lab 1, we're going to want to put this in universal time. They use their time zone. It'll be off by a couple hours, and the moons will be kind of in the right place, but a little bit off. It's best if you go universal time, turn off daylight savings time. Don't even have to set the location because we can turn off the ground, turn off the atmosphere. And let's see here. This is Saturn. So I'm going to go to Saturn. If you want to line it up the same as your images, you hit the little, and this is all explained in the videos, you hit the little telescope icon. It was just a minor adjustment there. And lastly, I just have to change the date, and that's right here. So this image was taken in 2019, October 17 at 0:50, and the seconds don't matter. If I click off, I can get rid of the words. And this should match the image perfectly. And indeed it does. Titan.
Hey, Dan.
Yes.
Sorry to interrupt. I've got a question. Could they do the same thing with the Julian day? Just enter the Julian day into Stellarium?
That is true. They could. There is an option right here for Julian day, so they can just paste that in there. Very smart.
Okay, thanks.
Yeah. So Titan, Rhea, Dione, Tethys, I guess that's Hyperion out there. And if you play with the brightness and contrast, you may be able to get some other things. What's that? A background star. I can see a hint of it there. Anyway, we're going for Titan. So that's Titan right there. And if I go to the next image, okay, this one has, often your images will be rotated because a lot of the telescopes are German equatorial mounts. And once you get on the other side of the horizon, it's flipped around. So sometimes you may want to rotate back, but again, there's Titan. Here's the next one. It's a little bit off on the edge, but if I rotate around, Titan, you can see Titan moving. This one's in the right orientation, so it's already moved. You can see it going around there, okay? And so let's just go back to the first one here. And measuring, we're going to go to the measurement tool. We've learned how to use this before to measure angular sizes. Except this one has a twist. You can turn on centroiding. When we did angular size of a planet, they're eyeballing both sides. Here we have a centroiding algorithm, one for point sources and a separate one for planets. So I turn on centroiding. The planet's off, so I'm going to click on the moon. And then before clicking on the planet, I'm going to turn on planet centroiding. And try to click near the center. But, if you didn't, let's see. Let's turn off planet again. Even if I go off, it should be able to adapt. Strange, it did not. Oh, there it goes. There it goes. See, it adapted there. It's just a different algorithm for centroiding on planets, which are disks compared to point sources. And then again, they're looking for the angular separation in arc seconds. It's right here. They copy this into their lab. Here. Now, I'll just point out with Neptune, Neptune's the easiest, as we talked about before, being so far away, its moon is really close. They should, sometimes they get confused, say, okay, that's Neptune, and the next brightest thing, that must be Triton. No, Triton's always right next to Neptune. It's the easiest one to do, because you don't need to use Stellarium. That is Neptune. And in a case like this, there's the planet. Hello, come back. Okay, turn off planet. Yes. And start with point centroiding. The planet centroid can be a little slow. If you click off the planet, it will pause for a minute while it's trying to figure out what to do. And that works just fine. Though sometimes if you're using lesser quality telescopes, these can blur together a bit, and you may have to, adjust. Got a bright target. Back it down a little bit to gain as much separation as you can. These are not blurred together, but you can imagine playing that game, trying to separate out the peaks, and then you just do a manual measurement. If they're blurred together, the centroiding algorithm is not going to work, and so you can just eyeball in that case. And I'll be adding that particular hint to the labs. It doesn't exist in the labs yet. Lab 3 has not been updated like labs 1 and 2 have been, but it's next on my to-do list. Anyway, then we're almost there. Once they do this, the next unit is taking this data and measuring the semi-major axis. So we have a graphing utility, and I'll show it to you in a second. They're going to put their measurements in, angular separation here, date, Julian date here, and it will look something like this. Basically, suppose you have something like Jupiter where the moons are crossing the planet and they go off far away and come back across again. So here's a crossing, and here's as far as Ganymede gets. It comes back and it crosses, then it gets as far away as it can on the other side, comes back. So 2 bumps is a period. The height is the semi-major axis. And so they use our graphing tool. It's linked here, but I already have it up. And right now it looks like this, where they can use the old version or the new version. Let's try the new version. And we're using the moon tool here. And I've measured all that Neptune data in advance. So I'll just grab it from a spreadsheet and paste. So I have my Julian dates here, the angular separations, and here I'll reset the model. I played with it ahead of time, so the model was already fit to that data. So it'll look something like this when they come in. And I don't know, let's set the axes first. On the x-axis, we have Julian date. On the y-axis, we have angular separation. Units are good, arc seconds. Title could be something like Triton orbiting Neptune. Okay. So the labels, the axis labels have been changed. Now we just have to fit the model. This is chi by eye, and it's not too hard, particularly if you have all 14 data points. If you only have like 5 or 6, it's a little bit more challenging. I'll start by moving the semi-major axis kind of up to that level, and I'll decrease the period until it looks like it may fit. Got a phase, slide it over a little bit. And then finally the tilt. If the moons are crossing in front of the planet, it'll go all the way down to 0. But Neptune is closer to face on. If it's perfectly face on and it's a circular orbit, the moon would always be the same distance away. It'd be a flat line. But there's some tilt, so sometimes it's farther, sometimes it's closer. And something like that. And I didn't even spend a lot of time trying very hard, but that's a really good. Now I could tweak it and get it through the dots a little bit better, and they should. They want to be really precise, because it turns out once we cube the semi-major axis, square the period, those errors add up. So the more precise they can be here, the better. Now we tell them.
Question.
Please.
Quick question then. What is the Julian date and how it is decided? How is it determined?
The Julian date, they're just measuring days since something. I forget what it is, like January 1st, 1900, or I forget exactly what date, but there's some official start date and they just count from that point.
Okay, thank you.
But the nice thing is it's already in decimal form, so they don't have to do the conversion. And then they save their graph, they sign their name, because this will be written into the EXIF data. So as you're grading, you can check. I'll show you how when we're grading it. One click, you can check and make sure they're submitting their own work and not somebody else's. You can have one student do it and then pass it around. And then when you check, you'll see the student's name. And that's something the educators requested and we built. Okay. And then just to wrap it up, let's see, go back to the lab. Here's an example. This is with the old graphing interface, but similar idea. They'll put their semi-major axis in arc seconds here, their orbital period in days here. Now we're going to determine the mass. And so first we need to convert this semi-major in arc seconds to a physical distance.
Hey, Dan,
Yes.
sorry to interrupt, and it's kind of a trivial question, but what's the major difference between the new tool and the old tool? Or did you cover this when you started this meeting? Because
I may not have covered it yet. So these tools were all written by undergrads as starter projects before I moved them on to Skynet and Afterglow and more advanced projects. And so, as you can imagine, the code base was ass. If it's everyone's starter project and it's written by a dozen people over the span of 10 years, it's a mess. And so I have a really good programmer, Reed. He recently has rebuilt all the OPIS tools. Next, we'll rebuild the MW tools into a common platform. It's the same platform we use for Afterglow. And so you can imagine mergers of these products in time. Also, we're using a new plotting program called HighChart that Kate recommended because there are all sorts of ways to make them accessible. We haven't done the accessibility work yet, but now under this new framework, we can. Under the old framework, it just wasn't possible. Things like adding audio to graphs for those who need it, can read things out. And if we do get this next grant in partnership with Tim Spuck, that stuff will be added next. Okay, I'm trying to wrap this up quickly here so Kate can have half an hour. So this is something I'm going to change. I don't like how this is done. I'm doing something in 2 steps that can be done in 1. So first, they go to Stellarium, their planet, the time of the observation, and look up how far away it was in AU. And then we're using the same geometry. I told you we use this in lab 2 to measure the size of the Earth, and we're going to use it again and again. Parallax, angular to physical sizes of galaxies. What I could be doing is taking their angular measurement that they just did in arc seconds and using this to convert it to a physical measurement. But for whatever stupid reason, I'm taking 1 arc second, converting it to a physical measurement at the distance of the planet, and then we use that to convert as a conversion factor. And after meeting with the educators, they want me to merge it into a single unit. This lab's gone through many iterations. It made sense in the past, but it doesn't now. So in the next iteration, these 2 will be merged. But right now, what we're doing is saying, okay, 1 arc second at the distance of the planet corresponds to how many AU? And again, here's that same geometry. The physical length here divided by the circumference of that big circle is equal to 1 arc second divided by 360 degrees. Solving for length, the distance they looked up in AU from Stellarium goes here. They convert their arc seconds to their 1 arc second to degrees, and then you have a conversion constant. There are this many AU in 1 arc second. They show their calculation, and then they take their AU and arc seconds from above, multiply by this conversion factor. I think you can all see how it'll be easier as 1 step, but this semester it's still 2 step. And they'll get a very small number because AU is the distance between the sun and the Earth. The distance between a planet and a moon should be a small number of AU, so a very small number there. They take their orbital period, which was in days, converted to years, so again, a small number. And then cube the one, divide by the square of the other. You have the mass of the central body. It's in solar masses, so it should be a small number. Like the mass of Jupiter in solar masses would be tiny. Each of these, they have a place to show their work. And then finally, we convert from solar masses to Earth masses by multiplying by 333,000. You get a certain number of Earth masses. They calculate a percent error, which can be tens of percents. Because if they're a little bit off, particularly if they didn't have too many data points, you take that error, you cube it, take this error and you square it. That adds up. But still, if they're within a few tens of percent, that's good. And then they discuss their sources of error. How well Afterglow selected the centers. It's pretty good. Difficulty fitting the orbital parameters, A and P, particularly if they only had a handful of measurements. I can't remember if I think I said it, but if they only have a few measurements, we actually encourage them to check their period. Let me just show that real quick. Back to the interface here. You can get, what's that? So 2.9. If I go to half the period, you can also get a good fit, and a third the period and a quarter the period, right? So we encourage them to just look up their period on Wikipedia, make sure they're in the right ballpark, particularly if they only have a few points. Maybe they mismeasured one of them, that kind of thing. We tell them to double check their period, and that will help them get the other ones very well. And then the other source of error is, that's it. Okay, so that's the end of lab 3. Sorry if I did that a little quick, but it all makes sense. And if not, there are of course the videos, and I encourage you to try it ahead of time. Okay, so I will stop sharing and turn it over to Kate. Kate, take the full.
And Dan, could I ask a quick question?
Yeah, please.
Yeah, and I put my note in the chat. My camera's not working today, but when I was playing with Skynet and was searching the moon, I got a strange message.
Yep. And so I'll be adding that instruction as well. When we tell them, so we now have the moon stuff in a different place, and where they the max phase, the default value for the max phase is 100%, and the default value for the max separation is 30 degrees. And that, that works for everything except when you look at the moon. You can't look at the moon if you have to look 30 degrees away from the moon. So an error message pops up saying you're going to need to set that to 0. I'll add that instruction to the labs. It's just because we moved that moon stuff up from lower down into there. It was needed for the MWU curriculum in particular.
Okay.
Astrophotography, right? We got to be really careful to avoid the moon.
Well, it seemed to be like a temporary snag, because when I got out and then went back in, then now it's fine, and it still says maximum moon phase 100 and minimum separation 30. So
it could be that the moon has now moved more than 30 degrees away. It's only during new moon that you'll run into.
Gotcha.
No, I don't know. But we could talk about it later.
Yeah. Okay.
And
Kate, so far my students haven't run into this snag, but
Kate, if you need to go over, it's okay because it's recorded. A few people will pop out at noon, but they always check the video.
Okay, thank you.
Over to you, Kate. And you're muted.
You need to enable screen sharing, Dan.
Thank you. There you go.
All right. I'm going to start off, get right to it, and then see if I can get my everything to cooperate. And I'll move you guys around a little bit here, and I think we'll be ready. Let's see what happens with slideshow. We'll see if this ends up on the proper screen. It does not. Let's try stop sharing, and I will reshare the other screen. Okay, here we go. All right, that should do it. You guys should be seeing my slides now, and yourselves and all manner of other things. So we'll get rid of that. So yeah, I've been really having a lot of fun the last couple of years working on the OPIS curriculum, and I look at how we have evolved as an organization. So Glass Education is only 5 years old, but we have our roots in the accessibility work that was done at Yerkes Observatory, where I was the education director for a number of years and a classroom teacher who learned everything that I know actually about astronomy is through my affiliation with the University of Chicago and the great teachers that were at Yerkes. So fast forward, we're very close to the Wisconsin School for the Blind and the Wisconsin School for the Deaf. And we have maintained a lot of work in accessibility. And over the years, I have actually gotten almost ornery about accessibility work. I am not a teacher of the visually impaired. I have some minor visual impairments myself, but do not live the life of a blind person. So I have become a huge advocate of advocating to you folks that whether or not, no matter what disability you're working with in your classrooms, is to lean on people who have the experience with those working with people with disability, with your students who have disabilities, so that you aren't having to invent all of this. This is not trivial stuff. And I think the expectation that a student comes into your class with a disability and you have a week's warning and thinking that you're going to make it accessible is a steep curve to climb. And so I want to be, your astronomy good fairy on this and fix problems. So this first slide, this is our every summer we have a team of people that come in, particularly during the summers, and we get a lot of work done in accessibility, and we work with people with vision impairments to make sure that, and people who have disabilities, to make sure that the work that we do is as accessible as possible. Now we focus, let me see if I can advance to the next slide here. I'm here today with Olivia Smithmeyer, who is one of those great people who has hung with us through thick and thin. She started learning about astronomy when she was just a youngster at Yerkes. She is blind and works with us to work on accessibility. In this picture, you can see her holding up our version of that very important chart on Skynet to see how, what's up in the sky. And so we work together to tackle some of those pain points, those accessibility barriers. And we focus on vision impairments and hearing, because Dan didn't put enough in their budget. No, we focus on those two areas, because if you are focusing on sensory disabilities and you accommodate for those, you really have hit a lot of the other disabilities that you will encounter in your classrooms, whether that is English language learners or print disabilities, neurodiversity. You will have hit a lot of those. So with the resources that we have, we focus where those resources can have the most impact. And so this is just a picture letting you know that this is some of the things we worked on during the summer. We work with hands-on materials, we code different things, we do a lot of things with 3D printing and sonification. Emily up there in the corner is hiding behind her laptop, showing off one of the sonification tools. And we have high school students running through OPIS and kicking the tires, because having what I learned from watching high school students work on OPIS or MWU is as we work with them one-on-one, what happens when somebody's coming into our courses without the sufficient incidental learning that they needed, or the sufficient background to handle the material well. And that goes to people with vision disabilities, hearing disabilities, but also those students who have been economically disadvantaged in ways that they just didn't get the exposure that we kind of just assume everyone gets. So those are some things we do here at Glass, and we have an awful lot of fun doing accessibility work. So our goals for working on accessibility with OPIS were really just to improve the accessibility of the existing materials in OPIS. Identify those key accessibility pain points. So where is it really problematic, and look at workarounds for them. And then increase the number of students with disabilities who are signing up to take OPIS. And that is something that last goal, we're in year 3 here, and we're so far failed to do that. And I thought that I had a plan that was going to work. And so we're looking at a supplement, which we're waiting on, to see if we can actually jumpstart people with disabilities identifying themselves and taking the course and giving us feedback on that. And that's a whole nother conversation, but just to let you know that we're still have an eye on that. And this is where Olivia is really going to come in this fall, because the start of this supplement, if we do get it, is going to be a little later than I planned. Olivia's and I and a couple high school students are going to go through OPIS step by step and look at what we've created so far, kick the tires on that, and make sure that we've improved things as much as we can prior to hopefully the start of a supplement next semester. So let me go through a few things on what we've done, and also to let you know that you do have students with disabilities in your classroom. I mean, you may not have gotten a heads up from your disability services office saying you need to accommodate, but the statistics are pretty clear, especially if you're working with freshmen and sophomore. They tend, if they had a IEP or a 504 plan in high school, the odds that they will identify coming into college are fairly low. Only 20% of the students going into college choose to identify or reach out to their disability services office. And there's a whole host of reasons for that. But even students with vision impairments, serious print disabilities will tend to not want to identify. So having accommodations in place is good for everybody. And you being open as the educator in the classroom saying, hey, I know you're out there. And I know that as freshmen or sophomores, you probably avoided identifying, but you may want to reconsider that. But here's what I'm going to do to try and make this class as accessible as possible for everyone. And since even OPIS started, the whole identification of neurodiversity, that language and that identification has really come into its own. And I honor that. And what I want to just give you a heads up on is neurodiversity does not simply apply to a more politically correct label or a trendy label or current label for people with autism or on the autism spectrum, but it really is looking at diverse ways that our brains process information. And so that covers all the things you see on the slide: attention deficit disorder, dyslexia, dysgraphia. So dysgraphia having to do with creating print material, processing hearing, and then producing print material from that, dyscalculia, autism spectrum. And then I am hearing some people with Down syndrome also identifying as neurodiverse. And that really is dependent on the person. So Bridget here that's pictured, she's a woman who is in her 30s and has Down syndrome and is working on her associate's degree. She's in college now, and the accommodation that she's learned over her lifetime with a person with Down syndrome, she's accomplished a great deal. So just wrap your heads around that for what it's worth. Just know that particularly the students with ADD and ADHD, our odds are they are not going to be looking for accommodations in your courses, but they're there, and working with them with some of the things, making them aware of some of the things that we've done in order to accommodate both print and or hearing and vision loss is also applicable to them. So one of the first things we did was we looked at all of Dan's videos and we made some changes. And I think Dan's probably pointed out to you where those are. And we took the videos that Dan's made and we created, just moved Dan's head around a little bit, made sure the captions were visible and correct. We corrected all the captioning on there and did a lot with arrows and getting rid of the extraneous material, all the bookmarks and tabs and the side, looking at Dan's desktop, as interesting as that is not going to help someone focus on the material you want. This also allows students with attention deficit to help them focus on what's important. And when you have low vision, working through a video and being able to have, where is that cursor? Wasting time looking for where the cursor is terrible. So we make sure that where your attention is supposed to be focused is possible. It also allows students to scrub through the video to points where they want to be to repeat information. And it should help with retention and acquisition of material as we go along. So one of the fun things, we fixed all the captioning, because Google does a great job of giving you a transcript, producing a transcript, but RR Library and we have to go through and hand fix all those, put the grammar into those videos. So we spent quite a bit of time doing that. They're in their own playlist connection under playlist in OPIS under improved accessibility. I do not claim that they're fully accessible, but this is a really good start. So it allows students, particularly who's using Zoom text, so that's a app on your computer, to zoom in on different parts of the screen. And that's different than using, Command plus to increase the size of the browser. That behaves differently, and it's preferable to use a separate app for this. So just don't assume that, oh yeah, it's accessible because somebody can use Command plus to make the browser window print bigger. That's not going to cut it. So just realize that that's a tool that people with low vision use often. So the other thing that we have done is we've looked at what is the novel vocabulary in each one of the OPIS lessons and made a list and tracked those to where they first appear. And that includes anything that would be novel for an ASL interpreter, or that also covers English language learners. So even today, Dan used the phrase plug and chug. Well, that doesn't have a very good ASL interpretation. So just having that prepared there is helpful. And if you were to ever have a sign language interpreter in your, in your courses, to be able to hand them this list and say, we're going to be talking about Lab 3. Just go to this spreadsheet and you can see what vocabulary we're going to have today, because only 20% of the vocabulary that you use in astronomy specific classrooms is going to have an ASL sign. So the person has to learn how to sign, or not learn how to, they have to be warned ahead of time that they have like 6 seconds to sign a whole bunch of terms, or sign explain things. So not just finger spelling out the word, but then doing an explanation, or there's a couple of signs you can put together that will substitute for that word. So, or they can get together with the person that they're signing for and agree on an abbreviation for electromagnetic spectrum. It's a nightmare. So that's why that is also very helpful. Where we'll plant this material in the future, I'm not sure, but it is available. Another thing that we also have agreed on a definition for each of those words that you can look up, and that's something that the OPIS instructors from the first year worked on with me as well. Finally, we have alt text. So alt text is for if you're using a screen reader, you want meaningful information to come through on your screen reader about the images that are in OPIS. So if you scroll through the images in OPIS, there's a lot of them. And deciding what was important about each image and how to explain that without giving too much information, or just what needs to be in the description and out. So that was a job that actually took a really long time. And we finally finished it this summer. We set aside time and we found an amazing intern that was really into doing the alt text. So we have a style sheet now for writing alt text for scientific textbooks. And I think we've really got a system going. Getting those alt text planted into WebAssign is something Dan's going to get to. Really, he's going to bug those people and make sure that those get into the WebAssign so that that's available. A blind person can be successful in the OPIS course with appropriate accommodations, and alt text is the biggest start to that. I think I will be presenting on the alt text style sheet at the AAS meeting, should you happen to be there. Okay, so then looking at your courses, determining which resources would be most helpful is something I can help you do. If you have somebody with a significant sensory disability, I would be happy to work with you individually. I want you to send those students to me. And even if people are simply low vision and they're having difficulty, or if they have a lot of difficulty with focus, or if they need to have something. A lot of students who are on the autism spectrum really benefit from having a tactile device with them. So we have tactile graphics that have been carefully constructed to go with the OPIS curriculum. And that's another thing Olivia's going to be helping with, is making sure that we have those completed. That is a really big job, and we're about 3 labs into that, totally completed. There's a lot of hanging bits out there that we still need to finish. And those allow us to download a PDF and then go over to your disability services department and say, hey, I need you to send this through a tactile graphics maker, or more lovingly known as a toaster, to make up the tactile graphic for the unit. And so each unit will have a set of accessibility accommodations, and you should be able to download those as a zip file. That's the final goal for this, and we're pretty close to that. So 3D modeling is another thing that we have spent a lot of time. I want to highlight and do a shout out to Emily Cisco, who's been with us for about 4 years. She shows up every summer, and now she's working on her PhD, still comes back and helps us with our 3D modeling. She understands her astrophysics and is able to help us make accurate models, adjust things, and come up with some of our best items for putting something in the hands of students. So even students who have full vision, are hearing there are items where having a 3D model is really handy. If you don't have a lot of experience with telescopes, and you go to OPIS and you look at that first picture with Dan proudly standing next to one of the prompt telescopes, making sense of that picture is tough if you don't understand how a telescope is put together. So a model that actually moves is helpful. And so that's one of the reasons why for each item that we can have a 3D model for it, particularly telescope model, is been part of what we do. So we also have activities that help explain what in a tactile way, what the aperture photometry, what is that software actually doing? So we have some of those on our back pockets as well, and lots of items to try and explain color, to explain filter. What you see here in this picture is an example of, we have different stellar profiles in the top right, and then we have the different filter from Johnson & Cousins and Sloan Digital Sky Survey. Those profiles are on the lower part, and explaining what a filter is to be able to line those two up and understand how they go together and what happens to the light coming from a star when you're applying a filter to it, is a concept that's challenging for all students. So when all students are looking at these trying to deal with this concept, they have to look at one image and look at another, and in their minds they have to put that together and overlay that for themselves. Well, that's not always that easy, and it's not that intuitive for everybody. So to be able to physically pick them up and move them, that's really cool. And I'm really gratified. This is the #1 downloaded tool from our website right now, so I'm seeing it as being pretty popular. I also gave away a lot of them last year at the AAS meeting. So so that's some of the things that just gives you an example of kind of the things that we're trying to think about as we go through adapting the curriculum. So what can you do this semester? And the first thing I would really beg you all to do is walk over to your disability services department and talk to them. Tell them that you probably have students with disabilities, that there is options within this course to accommodate them. I'm getting the big bucks to talk to your students if you have them, to help them navigate this. If the supplement comes through, that will be even a deeper commitment. We'll be able to add some dollar incentives to recruiting students. But for now, if you just talk to disability services. Almost nobody in disability services has a STEM degree. My experience is they're afraid to put students into science classes. They want to find the history of science, do anything they can to keep students with significant disabilities out of science classes, because accommodating it is really challenging and they don't personally have the experience. Also found that very few of you, few professors actually know or talk to disability services. So that's super important. Those people are skilled and talented, but STEM is typically not their strong point. And I want to be there to support all of them. Then tell students that support for disabilities is available for us if they need help. And I'm particularly interested in people with hearing or vision difficulties. And that doesn't have to be, you don't have to be blind to need support in these areas. You don't have to be use sign language to need hearing support. And significant print disabilities, anything, just send them our way. And then, you know, I would suggest looking at your own lectures and create an accessible template. I have information about that. If you have not run across how to do an accessible PowerPoint presentation, please let me know. I'll make sure you get passed on to some resources. And of course, if you're doing anything online, get yourself a good webcam and make sure that Zoom captioning is enabled for people with hearing loss or people who are just having trouble interpreting English well, that's available to them as well. So those are good places to start. There are a lot of other things that you can do, but this is an overview. We have been working with Dan's programmers to preserve the accessibility that was built into Afterglow, and hopefully at some point work on even deepening that, particularly through the sonification tool. And we worked with Reed to look at, there's a lot of adjustments that you can make to the graphing tool to make it increase the contrast, increase the font size. So those things are also available already. I think that should about cover it. I see that I left a slide on here of my favorite tool, but this is one of our Galaxy cards. That doesn't necessarily apply to what's happening in OPIS, but just to give you an idea, if you another thing that is available for download, and just letting you know the time and effort that goes into making sure that if there's a need for quality tools, that we put those together for you. And that is about it for me for now. I want to leave a few minutes for questions. Go for it.
Hi,
Right.
that was great. Thank you very much. Here at Muhlenberg, we're in pretty close contact with the disabilities people, but I don't think I've had a hearing impaired or visually impaired student that I know about in my class yet. Listening to you, I was thinking, well, this is great for the labs, but boy, I really would have to work a lot on my lecturing and on my PowerPoints. So I was glad you mentioned, you know, what you could do to PowerPoints. That would be very useful to me for all that class time where you're showing them PowerPoint presentations and so much would get lost. Are those resources readily available for how to make the PowerPoints more accessible?
Yes, I will make sure that I get those resources off to you. Yeah, I've done quite a number of presentations. PowerPoint, the tool I would recommend you working in. Google Slides are okay, but PowerPoint is much better as far as doing accommodations. It's not bad in Google, but I much prefer to work in PowerPoint. So that's where my information will come from. And then just doing simple things in terms of your pacing for your course, pausing, you know, making sure that you're not, if you have students with hearing disabilities or even vision losses, is, you know, when you're showing a visual and you're talking, you make sure you pace your timing out and watch for, allow sufficient time for people to focus on visuals, point out where people's attention should be on complicated visuals in the course, and help focus people's attention, and then just giving time with your language. So I've spoke really fast today. That's not cool generally. What I do with videos, if I have things recorded and I know I've talked too fast, I just go in before I upload it and I slow my speech down just a hair. And so there's ways post-production that you can do things to increase accommodations. But yeah, and I'm happy to talk to people more about that, specifically about how to do, what you can do in your lecture time. So good question, and way to go visiting your disabilities.
Can I add one thing to that, Kate?
Yes, Olivia.
Another big one, especially if you're dealing with a math or science class, is do try to work on using proper nouns instead of, move this over there and then divide by that. That means absolutely nothing. And the amount of time and energy that it takes to go back and figure out what in the world you were talking about is I mean, it's just immense. So the better, and even just in everyday speech, and again, kind of never mind disabilities, think of the number of times in life that there's just been this ambiguity and a tremendous amount of time and ink and everything else gets spilled trying to sort that out. It's just a really good linguistic habit to try to be precise and clear with your speech and use proper nouns and descriptive language. It's just really helpful for everybody.
I'm really glad you pointed that out, brought that up, Olivia, because it also, one of the things I wanted to make sure I reminded everyone of is that, the students with disabilities are in your classrooms, and the things into that having a disability, you're coming into a science classroom and you've had lots of years of experience being dyslexic, and you don't ask for any additional accommodations other than more time on a test, for example, or a reader for a test. But realizing that all those coping strategies take energy, and that students with disabilities, it can be very exhausting. Even with my fairly minor issues, I know that 3 hours on a spreadsheet ends in a migraine headache. And so there's realizing that you aren't faking it out or just trying to get more time, that if someone comes to you and says, or you see evidence that people are just exhausting themselves on your tasks, that to listen to what their needs are.
Yeah, in short, they're in your class or they're avoiding your class. And
That's a really good summary statement.
Yeah. And if you can find them for us and bring them to Kate, you will be our hero. And if we get this additional supplement, you will be our paid hero. There's incentives for the student, the instructor, and the disability officer, as I recall, built into this supplement. And not tiny amounts of money either, not ginormous, but substantial amounts of incentive money. And it doesn't last forever if we get it, but hopefully it'll be enough to jumpstart the process so it can continue in the future.
Yeah, our goal is to seed these learning communities so that OPIS becomes the identified disability access course to take, and then will hopefully spark continued interest once people understand how accommodations can be made and what to ask for. To tell students like with disabilities, like, well, just advocate for yourselves. Well, if you haven't had the experience and you don't know what to ask for, and you haven't had someone who knows the content bridge that for you, well, that's just silliness. And we put so much on students with disabilities, and sometimes we just use the excuse of they didn't advocate for themselves sufficiently. So I want to be that, and Olivia is going to be with me every step of the way.
Initially, we did this just because it's a good thing to do. And the primary thing I was looking at initially was making sure our software platforms are screen reader compatible, et cetera. But now that we're in 1.5% of all introductory astronomy students each year in the US are taking OPIS. I probably mentioned that statistic. I only learned it recently. That means we are hitting accessible people, and they're not getting the services they need. And as we continue to grow, we have a toehold. We're not 0.001%. We're 1.5%, and that could grow to 15% over the next decade or so, in which case we just really have to take this stuff seriously because we are hitting lots of them.
Yeah, and if you're not directly using OPIS or you've chosen not to know that it's out there and that it's accessible and it's covering what content it is covering. What can I grab from that accessibility pile? And we're putting all of those materials, we've planted them on our website. So I'll just throw that in the chat, glasseducation.org. If you go to the resources section, we are piling all of our 3D print resources and our tactile graphics on that site. And eventually we'll have it broken down by lab for OPIS. So.
And Kate's email is just kate@glasseducation.org. Glass is GLAS.
Yeah,
There's
just
Glass Education and just Kate @ and you can get directly to her. Anyway, we're about 10 minutes over, so if there's nothing else, we'll technically end the meeting, but if anyone wants to stick around and ask questions, feel free, because I'm waiting for my TAs who will show up in 4 minutes now. So thank you, Kate.
and thanks, Olivia.
Hey, Dan, I have a question.
Okay.
So, when you go and you look at all the telescopes that are available and you click them all, because now we just want any telescope because we're always fighting for time now with reduction of available telescopes. Then when I go look at the weather and so forth, I see all these telescopes that supposedly are available, but then I go look to see, okay, is there bad weather or anything? I see hardly any telescopes. It's like, I was looking last night and I'm like, where are the Australian telescopes? I see USASC is back online, but that's about it. Like,
we now have a second USASC, so we made an improvement.
Yeah, I saw that. That's good.
Under Australia, there's currently only going to be one Meckering, unless it's down due to weather. Though we are planning to return to sighting spring. We got those 3 telescopes working, but they didn't work for long, and we have some weather stuff to address. But 2 of them at least will be back after the next trip there, which is coming up. And CTIO's reached out to us, and I do anticipate getting our CTIO telescopes back shortly.
Oh, that'll be great. That'll be great. Yeah. But it still seems that when I go look at the telescope sites page just to look, there seems to be so fewer numbers there than all the colored lines that, say, hey, these are all available, and all the telescopes are picked. So I tell my students, pick every telescope available. And then if you go over to the sites, it's like half of the ones you just picked, there's no information on weather or anything on them.
Yeah, so the Skynet Live page is whatever's connected at the moment. Some telescopes, they take them down during the day and put them up at night. Some telescopes are, these are our partner. The prompt telescopes are the ones that I'm responsible for. The partner telescopes, it's up to them when they want to connect and not. There's no contractual obligation for them to be on. And so we're just counting on the fact of, given the sheer numbers, there should be a handful on any given night.
Okay. All right. So if I don't see them in the telescope sites, then they aren't on. They aren't available then, even though we picked them.
Yep, on Skynet Live. Though they could pop on at any point. So that's why you select all, at least till we get CTIO back. You select all. And then if you go to the Skynet Live page, you can see what's on at that moment. And hopefully at least some of the ones you picked are on. And the image quality that we get back from the other sites is not as good as Tololo. I'm seeing that, and I'm seeing students' Jupiter and Saturn images coming back. I'm like, okay, it's there, but it's not what we're used to with Tololo. We're in better situation now than we were during the pandemic, where we were really stringing along on just 2 or 3 telescopes. But hopefully this will be rectified very soon. They have reached out.
All right, so I'm trying to do the moon.
The moon broke up a little bit, but I'm guessing you said the
moon mosaic in the MW.
Oh, okay.
Can you still hear me?
Yep.
In the MW, the moon mosaic. It appears from all the possible from all the possible telescopes, it's only Meckering that we can do it with right now. Is that correct?
So for the moon mosaic, you do have to select a single telescope. I would pick Meckering, or I would try the USASC telescopes.
Okay. Do we have on the USS telescopes? Do we have the okay? So do we have the correct times and stuff given in that sheet, whatever? And would they be like a 5x5 grid?
Yeah, they are. The USASC telescopes are identical to Prompt 5.
Okay, good. Oh, so I can use them just like Prompt 5. Okay.
Yeah, that's right. In the write-up, it's all written around Prompt 5, which is not available right now. And so, but Meckering and both USASC telescopes originated at Tololo, and they are exact copies of Prompt 5 and Prompt 2. There could, in theory, be exposure time, ideal exposure time differences, but when shooting the moon, you know, as long as you don't saturate, you can
Okay.
be off in the exposure time and still looks just fine.
Okay. That's good to know. Both USECs are just like Prompt 5. Good to know.
Yeah. USAS 2, which just came online, used to be Prompt Athabasca, which never really saw any action. So we picked it up from Athabasca, moved it to USAS. That's Daryl's site, and Daryl's amazing. And so he's got it up and running now. And I just added it to the OPIS and MW lists 2 days ago.
Okay. So it will show up as one of the color coded things at the bottom of Skynet. Now.
Yeah. And I think
Okay.
it's a full filter set.
Good. Great. Okay. That's good to know.
All right.
Are there other people still online? I can't tell. I'm on my phone.
Yeah, my TAs are coming in for our TA meeting, which begins now. But if you have any final questions, I'm happy to answer them before I jump in with my TAs.
Hi, Dan. Thank you.
Thanks, Brad. You good, Jim?
Yeah, I probably will just talk to you privately, separately. I know you got to go to your meeting. That's why I was wondering if anyone else is still online.
Yep, you're the last of the educators, and now
Okay.
the TAs are here. So
Okay.
I'm gonna stop the recording and start my TA meeting. But what's today? Wednesday. So I'll be online with Cluz's group tomorrow, right? Cluz's group is meeting tomorrow.
Yeah. Oh, that's a good question. Was it like they're every other week?
Every other
So,
week. Let me
so it
check.
might have been
Let me
because
check.
I think it's next week. I could be wrong. Trying to remember.
Yeah, it is not this week. But just send me an email anytime you want to chat, and I'll try to make
Okay.
it.
Okay. All righty. All right. Thanks.
Sure.
All right.
Okay, I'm looking for the Zoom window, and I am going to